Right, let's now look at scanf's return value. That function returns some information to us. Right, we weren't using its return information before. You can choose to do that. You can ignore information that a function returns. Go back to its prototype. When we first looked at it, we said that scanf has a data return type of int. Right, it returns some sort of integer value. It returns the number of items successfully read. The number of items successfully read, that number relates to the number of format specifiers in there, right? How many percent Fs, how many percent Ds, how many percent Cs do we have in there? Right, so on success, the function returns the number of items of the argument list successfully filled. Right, if we're trying to store something, in this case, in our argument list down here, we're trying to store something in I value. Right, so did it fill that? If it did read something and write something into its memory, scanf should return the value of 1. Right, so this count can match the expected number of items, or it can be less, even 0, due to a matching failure, right? A reading error or reaching the end of a file. We're not reading from a file. So if we fail to match, pattern match, right? If anything else goes wrong with the stream, it'll return some sort of error. Right? So what we're going to do now is we're just going to try to read in a value and store it in another variable. Let me pop up code blocks here. Right, I'm going back to the example where we were working with month, year, and day. These are all integer types. They've all been initialized to the value of 0. Created another variable called ret value for return value, and I just initialized it to -999, some sort of known value that we're starting from. I'm going to prompt the user simply to start out by entering one item, right? We want to enter the value for month. Month is an integer. We've got %d here to read that in as a base 10 integer. It should store it in the value of month. What we're going to do then is we're going to store the value that scanf returns in this variable. So return value is the name of the variable. Right. This is our assignment operator. The way an assignment operator works is it associates from right to left. So the expression on the right-hand side of the operator, this expression, this call to scanf, is evaluated first, meaning our call to scanf will run first. We'll capture that information that scanf returns. We were ignoring that before. We'll capture and assign it to this variable, right, named ret value, return value. And then what we'll do down here is we're going to go ahead and print out what we stored in return value so we can see that. We'll also print out what's been stored in our variables. And then we'll start using day and year in our next examples. Let's build and run. Right, now we're just trying to read in month. I'll type in 8. Right, we can see now that scanf returned the value 1. So the call to this function, because it successfully read one item in and stored it in month, right, it returned a value of 1. We assign that to this memory location, this variable named ret value, right? And then we printed that information out down here, right? So when scanf is successful, right, we asked it to read one thing, we'd expect it to return the number 1, it did. All right, let's see, let's run this again. Let's make scanf fail. All right, so we know that if we type a non-numeric character such as the letter K, this should fail. Scanf returned the value 0, meaning it couldn't read anything, it read 0 things. Then we can see we have our initial values in month. It wasn't able to write anything in there, right? So when scanf fails, it returns 0 in terms of it read 0 things. Right, let's ask now scanf to read a second argument. Now let's do this pattern matching. We want the user to type / and we want them to type in the day. So let's go ahead and give it the address of day. We'll tell the user we want month / day. We're now asking scanf to read in two things, right? Read in one thing, store it in month, read in another value, and store it in day. So when scanf is successful, we expect this function to return a value of 2, right, if it reads both things. All right, now we're going to type 8/1, and now we can see scanf return the value of 2, right? This function returned, this expression evaluated then to what this returns, the number 2, stored it in return value, Right here, when we print it out, we can see the 2 that it's stored. We can see that month now has the number 8, day has the number 1, right? We didn't ask it to do anything with year, so that still has its initial value. Right. Let's now make scanf fail. We're going to type A. We're not going to type the /. I'm going to type a space, and now I'll type the 1. Hit the enter key. Scanf returned the value of 1. The reason it did was it was successfully able to read in the first 8. Right? We didn't have to give it any sort of specific pattern to read in this. So it read the 8. Because we failed to match the pattern of the /, scanf failed. It couldn't read the number 1. So it successfully read in one thing. We can see that stored that into the month, number 8, the one thing it read, and that's why it returned a value of 1. Right? When it read both, it returned a value of 2. If it can't read any, we'll see it return a value of 0. So if we run now, and let's type K/1. Right, now it fails because the first character that we typed in, a K, is non-numeric. It can't read that and store it in an int. It just, scanf fails to read anything else it returns. So the value it returned was 0 to indicate it couldn't read anything, and we can see month, day, and year all have their initial values. Right. So when we learn to do error checking, then we'll learn then to be able to check for these different values. Let's ask it to read in year as well. So we'll put that in for that other pattern. All right, so, and ask the user to type in that. And so if we're asking it to read 3 things. If it reads all 3, we should see a return value of 3. All right, so 8/1/2014. That should be successful. Look, scanf returned the value 3. We see it stored 8, 1, and 2014 in our variables. If we run it and run the example, we only type 8/1/2014. Right, I'll violate that input. Well, it only returns 2. It's able to read the 8. I matched the pattern of the /, so it can then read the 1, but it couldn't read the year because of the K. Similarly, if we make it fail in other ways, we could make it read just the month. Right, I can type the 8, but now I cannot match the pattern. Maybe I'll just put an exclamation mark instead of /1/2014. Right, typo there. Scanf returns 1. It was able to read that first 8, but then it didn't match the pattern. The exclamation mark didn't match the / we expected. Scanf stopped reading. Right, so when we say it failed, we failed to read. It returned the value of 1 to let us know it read in one thing successfully. Right, in that case, we would know that it read in the month. That's the first thing we asked it to read. Right. So when we learn to do error checking, when we start learning if statements and other control structures, we'll be able to somewhat recover from this bad input in terms of prompting the user to enter something again if we don't read it the first time. Right. So that's how we can use scanf return value and the concept of a return value.